Hello out there. If you are watching on YouTube, and momentarily I hope folks watching here in person. My name is Logan. This is a GRE free prep hour. We host a couple of these every month. So if you haven't already, definitely check out the full series. The full series is on YouTube. I am a GRE teacher here at Manhattan Prep. We teach courses, mainly online courses. And for those of you who are here, hello, Emily, hello, Lucy, hello, Sophie, hello, Tassine. What we're going to do tonight in this free prep hour is quadratic equations. So I've done a number of these over the past year. And what I usually try to do is find a topic that we haven't done much of in this series, because as much as I appreciate y'all being here today, most of the viewers of this series are going to watch this at a later date on YouTube. And if we already have another video on YouTube of that subject, then it's just a little bit less helpful. Well, something I found that I don't think we have a single full lesson focusing on just this for the GRE is quadratic equations. So that's going to be the focus of the night. And I do want to caution that this is not the most important topic on the GRE. This is a topic that fits in, I would say, the advanced bucket. And here's what I would usually say about most of the topics in the advanced bucket. No matter what score you're trying to get, it's good to be aware of them so that when you see a question about a quadratic equation, you might be able to diagnose it. And if you happen to have this topic as a strength, you can have a chance of getting it. But these problems are going to be a little bit harder than average statistically, which means it's not a topic that's worth really studying a ton unless you are aiming for a really high score and you're getting close to there already, because if you're, say, in the 150s as opposed to the 160s, it's just very likely that you have some other lower hanging fruit topics to improve on. That said, we want y'all to be ready for everything. So let's take a look at quadratic equations. First off, what are quadratics? Well, there's a little bit more to it in the real world, but as far as we care on the GRE, we're talking about equations with x squared terms, or y squared, or z squared, or whatever the variable is. If it does not have a square, or if you cannot make it have a square, not really dealing with a quadratic, probably a linear equation or just some other kind of equation. Why are these equations different? Why do they have their own unique challenges? We're going to talk about that. We're going to talk about how this squaredness gets things a little bit weird. And by the way, those of all who are here in person, I believe you should be able to ask questions with like the Q&A feature. And you should be able to chat with me as well. So if you use the chat feature, I will be able to see your questions, though you are not able to come onto the microphone on these seminar sessions. Okay, let's get into why the x squared make things weird. To start understanding, we just have to look at a really nice and simple equation. X squared equals 81. Usually when we see something x equals, we know there's just one option. X is something, and we just got to figure out what that is. But there is more going on here, because technically from this, it is possible that x equals 9. And it is also possible that x equals -9. Just plug those back in and you'll see why. 9 squared gives 81, -9 squared gives 81. Same would be true for anything squared equals a positive number. There's going to be two options, a positive and a negative version, to create that one positive number. Built into this, by the way, is something that we're not going to deal with a ton tonight, maybe a little bit later, but it is important to know about quadratics and squaring things. Squared, or I say anything squared, is positive or 0, technically. 0 squared is 0, but anything else squared is positive. Because if you take a positive and you square it, it's still positive. If you take a negative and you square it, it's now positive, because the two negative signs cancel out. And this simple fact is going to come in handy for us a couple times. And this simple demonstration here starts to show us the first reason why quadratics are weird, and really the main one, which is that quadratics can have and often do have two solutions. So we have to do a little bit more work than usual to uncover both of the possible solutions. Let's hold on to that knowledge and look at this other situation, which is not exactly a quadratic equation in and of itself, because I don't have x squared or a squared or anything here. But I have a times b equals 0. If a times b equals 0, I know something. I know that either a equals 0, all right, in the middle here, and or b equals 0. If you see a, b equals 0, one of those two variables has to be 0. 0 is a very special number. There's only one way to multiply and get a 0, and that's if one of your multipliers was a 0 itself. Or maybe it's possible both of them were. I'll count this as another key fact. If two things multiply to 0, one of those two things must be 0. What does this have to do with quadratics, though? We're not technically squaring anything here. Well, we're about to get into that with truly a blast from the past and really the meat of quadratics, and that has to do with foiling and reverse foiling. I have an equation here on the screen that we're going to come back to, but for a moment here, I want to actually block that out and block this out, and we're going to talk about foiling. Anybody out there, tell me in the chat, do you remember from your old math days, what is FOIL? What does FOIL stand for? It's an acronym that a lot of folks learn in sort of middle school or high school math. Yeah, Sophie's got a first, outer, inner, last. And Sophie, can you tell me when do we do foiling? What is that first, outer, inner, last? When does that come into play? Quadratics, yes. Specifically, we're usually going to see it if we have something that looks kind of like this. Just going to make one up here. X plus 3, x plus 5. We can call this two binomials. If you see two binomials, or basically two-term sets here, two pairs of parentheses, each parentheses has two things in it being added or subtracted, that is when you get to use FOIL. And as Sophie pointed out, FOIL is F-O-I-L, first, outer, inner, last. And that's basically just a reminder acronym to help us remember, in order to multiply this, we need to distribute the two first terms, the two outer terms, so all the way on the edges, the two inner terms, the 3 and the x, and the two last terms, the last term of each. So we get x squared, x times x, plus 3x. Oh, let me go in order. The way I did it. F is x squared, outer, x times 5 is 5x. Inner, the two ones on the inside of the visual, 3 and x. And last, the two at the end of each pair, 3 times 5 is 15. And then typically what's going to happen is these two things here combine. And after you have FOILed or fully multiplied two binomials, you tend to get a trinomial when doing this topic on the GRE. X squared plus 8x plus 15. So far, this is probably pretty familiar. If you have ever FOILed, you likely are getting some things, some blasts from the past right now. What is a little tougher can be reverse foiling. What do I mean by that? That would be taking this and going backwards to produce that. And I'll show you how to do that right here. if you are, well, let me switch back to blue. Reverse foiling. Really what you need to do is find these numbers. You basically have two slots you're trying to figure out. What was that one and what was that one? To do that, you need to find two numbers that multiply to produce the last number in the trinomial, and add to produce the middle number. So here it's multiply to produce 15, add to produce 8. I would recommend that you start with multiplying, finding two numbers that multiply to 15, because it's always easier to find two numbers that multiply. And in 15, it's particularly easy because you only have 1 times 15, 3 times 5, -1 times -15, technically, and -3 times -5. It is good to remember the -1 sometimes in this process. Once you've identified the list of candidates, you basically give each one more test and say, which of you adds to produce 8? And it is only this one. So I got my list of candidates, and only this pair adds up to produce 8. And so if I was going back in time and trying to fill these two slots of the 3 and the 5, now I've got all the info I need in order to fill it. Okay, it gets harder than these. This other example I've got on the screen is not too much harder, but it has a little bit of a twist. Y'all who are here, try this out and then send me a chat if you figure out what the two numbers are, how we're going to go from this to basically y plus something times y plus something. Tell me in the chat what these two numbers are once you find them. Lucy, that looks good. Emily looks good. All right, getting a couple good answers in here. I got -2 and 4, and that's right. I can put a 4 here in the first one. And then in the second one, I'll switch this from a plus to a minus. We can always do that if we need to. How do I know that works? Well, -8, if I want to multiply to that, I can do 2 times -4. Here, let's do it like this, 2 times -4, -2 times +4, 1 times -8, and -1 times +8. Those are pretty much my only options. Which of those adds up to a +2? It's just this one, -2 and 4. Ding, ding, ding. Those are our two numbers. So this starts to show us that the positive and negative sign of the figures here, or the numbers here, the 2 and the -8, are quite important. Well, what do we do next? What's the point of all this? This here is still true, that all this stuff equals 0. And remember this, if two things multiply to 0, one of them must be 0. Well, what have we done? We have created two things multiplying to 0. What do we do with that information? Set the quadratic equal to 0. Here, it already was equal to 0, so we didn't have to go out of our way to do that. And then it can be factored to find the two solutions. We did our factoring, or our reverse foiling, as I called it. And now I can take this and say either y plus 4 equals 0, or y minus 2 equals 0, y equals 2, or y equals -4. So one of the weird things is that we kind of have a sign flip. +4 is the number we fill in this blank, but the solution turns out to be y equals -4. -2 is the number we filled into this blank. +2 is the solution here. So it would be correct to say that the answer to this solution is y is 2 or -4. We don't know which it is. They're both possible. And if you plug that on in, you will see that they both work. They both create a true statement. Okay, what we have done so far is basically quadratic equations 101 as it applies to the GRE. So those of y'all who are here, nice to see you. Yuan and Samarji, I think, joined after I had called out the names of those who are here. Nice to see you. Tell me in the chat, y'all, is this coming back to you? Is this something y'all already know, or is this feeling tough? Tell me in the chat, like, how do you feel about what we've done so far? That'll help me know how fast to go the rest of the way. Samarji says coming back, LOL. Yeah, we do a lot of this back in like, I don't know, 8th, 9th, 10th grade range. Anybody else? How's it feeling so far? Easy, hard, or what? We got the whole range. We got the whole range of answers in here. If this step that we've done so far, like basically, most importantly, the reverse foiling, finding, I should have kept my little 1-2 punch here, but finding the two numbers that multiply, let me make that small, that multiply to the last number and add to the middle number. That's really the main skill. I don't know if it's the main skill, but that's a very important skill in solving quadratics. And if doing this step to get from here to here is feeling tough, a good thing to do is practice a bunch of these with different numbers, using whatever resource you have. See what quadratics equations practice they might have. And if you do a bunch of these, it will come back. Let's keep going, and I want to talk about the quadratic formula. And I'm also going to introduce something that's going to make some of my phrasing a little more sharp in terms of describing how we do this. And that is this right here. This is not the quadratic formula. This is a classic form of a quadratic equation. You could call this like a standard form of a quadratic equation. And what do you notice in here? You have the variable x shows up twice. And then you have these three coefficients, a, b, and c. So let me label this. In blue, we have one variable showing up in a couple different ways. And then in the orange, we have three, I'll call them coefficients, numbers. And a more precise way of writing what I was writing before, now that we're looking at this in kind of a form with these abstract A, B's, and C's, is that to reverse foil, find two numbers that multiply to C and add to B. Instead of just saying the last number and the middle number, C will be that last thing getting added or subtracted. B will be the multiplier on X. But what if you can't do this? For example, what if C was like 17 and the only factors of 17 are 1 and 17 itself? And what if B was something that is not the sum of 1 and 17? you can still solve it, technically. It's just a little bit more annoying. And what if A is in the mix? We haven't even seen this yet, but it is possible to see something like 2x squared plus 4x plus 7, just making this up. It is possible to have this coefficient there on top of the x squared. That is where this other old thing comes in handy, the quadratic formula itself. Now, this is rarely needed on the GRE, but it is something that it can come in handy to know every once in a while. What is it? It's just a straight up formula that seems like it's out of left field to find the possible values for x. I don't even necessarily recommend studying the quadratic formula a bunch. Here, I'll label that here. I don't really recommend making the quadratic formula a major part of your GRE studies, because it really is true from our experience that most questions that test you on quadratics, you will be able to resolve without resorting to this kind of hard to remember formula. Technically, it is fair game for them to give you something that requires this formula to solve. For example, if there is a coefficient A, one of the best ways to solve it is to incorporate that into the quadratic formula. And using the quadratic formula, if you remember it, is not so demanding in terms of strategy. You just kind of drop the numbers in. You drop in your A's, you drop in your B's, and you drop in your C in this one place right here. But it is a little bit demanding, and just in terms of remembering this, and it is a little bit demanding in terms of doing all the arithmetic right on your paper, because remember, the GRE calculator is not going to really be able to do this, so you're going to have to do this by hand on your paper. Negative b plus or minus the square root of b squared minus 4ac over 2a. It's really a mouthful. If this like comes back to you naturally, if the quadratic formula is something you used to love, which can happen, then yeah, maybe it's worth just making yourself a flashcard on this so that you've got it in the back of the memory bank in case it shows up. And I will add a note here, rarely needed in the GRE. And like I said, might use it if there is a coefficient A in front of the x squared. Or if the C value is not easily factorable. These things just don't come up all too often on the GRE, so that's why this is not a major study topic, the quadratic formula. Okay, let's get into the business of actually trying some more of these problems. And we're going to do a couple basic-ish ones and level up to show some of the other trickier ways that quadratics can show up. Okay, so this one is that I'm going to pop on the screen in just a moment is a pretty simple test of, can you get the equation in the right form and then do the steps that we practiced on the screen a minute ago regarding reverse FOIL. Try it out. And let me know in the chat if once you get an answer. And if you're stuck, you're not sure what to do here, you can let me know that in the chat as well. And I'll give you a hint. Okay, let's try this. At first glance, you might not even notice that this is a quadratic. So this is kind of a reminder that sometimes quadratics might be hidden, where, there's no z squared when I first look at this, but if I try to solve for z, since they asked me what could be the value of z, what's the first thing I'm going to do? I'm probably going to multiply by z on both sides. So I cancel my z's over there. What if I remember to multiply this side by z? What am I going to get? 36 equals z squared minus 5z. By the way, I learned back when I was a physics student always to write my z's like this with a line through it. I never did that before, but it's very important when you're doing math. Why? Because otherwise they look exactly like 2's. So if you ever make this mistake, a z and a 2, you can prevent that by drawing a line through your z like that. 36 equals z squared minus 5z. Okay, now I can see clearly this is a quadratic. I've got my z squared, I've got my z. And just so y'all know, whenever you see a z squared and a z, or an x squared and an x, or a squared term of a variable, any variable, and then a power of 1, or a regular term of that same variable, it's very unlikely you're going to be able to solve it a normal way without doing a quadratic process of some sort, because anything you do is going to wind up with a z still hanging around, or like multiple forms of z still hanging around, I mean. So what do I want to do here? Well, I remember that it can be helpful to get a 0 equals. So I move my 36 on over. And now I got to ask myself, okay, what numbers multiply to negative 36? Maybe 4 and negative 9, 9 and negative 4. And I realize, 4 and negative 9, actually the first one I wrote, that is going to add to that. Maybe you started with other guesses, maybe something like 3 and negative 12, and you realize that's not going to do it. 6 and negative 6, that's not going to do it. If you do a lot of these, it'll start to be second nature, and you'll start to kind of see more easily which one you'll get. Once we know it's 4 and negative 9, we can set up z plus 4, z minus 9. And now I know that z is negative 4, or z is positive 9. Remember, I get the switch to negative 9 to positive because the question is, how could z minus 9 be equal to 0? Well, z would have to be 9. On the other side, how could z plus 4 equal 0? Well, z would have to be negative 4. So negative 4 and 9 are my answers. This is one way they could ask you about quadratics. This way would be one of the more straightforward ways. And what we'll take a look at in the next 30 minutes, the second half, is just some of the twists that they put on it. Any questions so far? If you have any, drop them in the chat, and I'll come back to this. As it is, I will move us on and talk about special products. Here is where you might want to get your flashcards out if you're a math flashcarder, which I recommend being a math flashcarder if you've got any formulas to learn. There are a few types of quadratics, places where we're squaring things, that result in very specific patterns that the GRE likes to use. Here we go. Oh, my animation is a little wonky there. Let's focus on this version. Let's go one by one. If you ever see a plus b squared, so something plus another thing squared, this would be two paired binomials because, if we wrote this all the way out, it would be a plus b times a plus b. That is always going to lead to this. A squared plus 2ab plus b squared. Worth flashcarding that. We'll see this in action in a minute, and that will make it a little bit easier to get a hold of this, of why this can help. But first, quote unquote, special product here. Next one. If you see the same thing, but inside of the parentheses, it's subtraction instead of addition, you get the same result, but instead of adding the middle term, you are subtracting the middle term. So down here, a squared minus 2ab plus b squared. And then down here, if you have, instead of something squared, you have the same two terms, so still a and b, but you're multiplying one addition pair and one subtraction pair. You just get a squared minus b squared. Nothing in the middle. Each of these is worth flashcarding. And what I would advise to put on your flashcard is like an example of it with real numbers, because without the real numbers, it can get a little bit confusing. What I want you all to do is try these. Each of these lines up with one of the ones up there. See if you can find basically the expanded version like these of, or excuse me, these are the expanded versions. See if you can find the like unfoiled version of these three. Try it out. And like before, let me know in the chat when you're done or if you get stuck on anything. Oh no, I revealed an answer for a second. If you're here, let me know in the chat where you're at. Is this feeling approachable, or is this feeling kind of like, huh? And were you able to translate any of these? Got some answers in there from Jan. Jan, thanks for sending those. And yeah, also, these are not impossible to get without knowing the special products. For example, if you just reverse FOIL this using the same process we've been doing, you will get the correct answer, which is x plus 1, or x plus 1 squared. If you get this, if you try to reverse FOIL this using the process we use, you will find a minus 2 squared. an example of this one here, where our A is A and our B is -2. And then if you trying to reverse FOIL this, remembering that it's possible for the middle number to be 0, you would get x plus 3, excuse me, z plus 3, z minus 3. So the B term here is 0. If you're ever wanting to follow the sort of typical reverse FOIL process and you don't see a middle term, just imagine the middle term coefficient is 0. Plus 3 and minus 3 does add to 0. So you're still following the same process. So we have here in the same order as on top, the x, basically x plus y squared, or x plus 1 squared in this case, matching this, a minus 2 squared, matching the a minus b squared, and z plus 3, z minus 3, matching the a plus b, a minus b case. There can be examples where it's a little harder to identify the results than just these. And what I would say as like something to remember a bit of is that if you notice a perfect square at the end of a quadratic binomial or trinomial, it might be a special product that you can use as a shortcut or as a bailout if you are not solving it another way, because all three of the special products end in b squared, b squared, b squared, b squared. So if it's a special product, you have to have a square term, a square number, something like 1, 4, 9, 16, 25, etc., in that final spot. And so if they pick a square number in that final spot, it's a good sign. They're trying to see if you notice that it's a special product that you can use one of these shortcuts on. Okay, let's keep going. See some final examples of how they will do quadratics in QC questions. QC questions are quantitative comparisons. So here's 3 of them on the screen. And just real quick, before you dive into all 3, I'm going to block out the bottom 2 and put a little reminder up here for all QC questions. QC stands for quantitative comparison. There's 4 possible answers. A means quantity A is greater. B means quantity B is greater. C means they're the same. D means not enough info. Can't tell which side is bigger. This is a classic GRE problem type. If you haven't done much GRE studying yet, you will be doing a lot of a lot of quantitative comparison questions. It's actually the first 7 or 8 of every single math section is 7 or 8 questions in a row with this format. These 4 answer choices, a quantity A and a quantity B. Okay, so that said, here's 3 questions. I want you all to try it. Try all 3 and let me know what you find. Let me know when you're done with the 3 and tell me which answers you got for each of the 3, A, B, C, or D. Try it out, take like 3-4 minutes. If you finished any of the three, even just the first one or the first two, let me know in the chat. I want to see or hear some about how y'all are tackling these. And welcome in Charmy, I think just joined. We are talking about quadratic equations tonight. Got a few examples on the board of questions involving them. Okay, I'm going to start going through these. I know some of y'all might still be working, and if that's you, no worries, you can keep going. Though it's possible we will we'll pass you at some point. We'll see. That's also possible, particularly down in the third one. We're not going to necessarily be reverse foiling this down here, and if that's what anyone out there is doing, I have good news. There's a better way that we'll get to in a few minutes. Okay, up at the top, this goes way back to the beginning of the night. What's something that we know about squaring things? Anything squared is positive. Z squared has to be positive or 0. There is no way that z squared can be a negative number. So what does that mean? B is bigger. And B is our answer here. Why? Okay, well, that's the opposite. Don't have a heart attack. A is greater. If A is a positive or a 0, it has to be greater than -3. -3 is always negative. Z squared is always 0 or positive. So A always wins. This right here is a little lesson. If you haven't done many of these quantitative comparisons before, very, very often, it really truly is about comparing and not calculating, where you don't need to know exactly what Z is. Z could really be anything. All that matters is A is bigger than B, because we got a squared term over there. Down in number 2, we're going to see something very similar happen. Sometimes people do this, but this is not quite the way. They see y squared plus 2y plus 1, and they reverse foil that. They say, okay, y plus 1, y plus 1. Maybe this is from a reverse foil mental process, or maybe it's from remembering those special products. This is one of those special products. And then they say, okay, so y is -1, right? Because if I have this equals 0, then each of these is going to tell me y equals -1. So -1 versus 0, B wins. But no. Why not? Anyone, any ideas in the chat? Why is this not the way to go? Something is wrong here. Zero is greater than -1. And -1 seems to be what I would get from quantity A. Sophie, you said in the chat we don't have enough info. Can you elaborate, perhaps? What what more info would we need to know for sure? There you go. Can we assume that quantity A equals 0? That's what Sophie just asked in the chat. Are we allowed to assume that quantity A is 0? No. And that right there When I added the equal 0, that is the illegal move. I can't just say, hey, I see a quadratic, so I set it equal to 0 out of nowhere. The first part of what I did was right. So I get a check mark for basically this factoring. It is y plus 1 times y plus 1, but I get a red mark for putting the equal 0. And without the equal 0, I can't say that y is -1. And I can't come here and say this is -1 versus 0. And I can't come over here and say it's b. So I have this chain of reaction that started because I kind of invented this equals 0. So great point there in the chat. However, we do ultimately have enough information to solve this one. And it comes from a different way of reinterpreting these paired binomials, not by setting them equal to 0. That's what we can't do unless we have an equation already set up. But by seeing that is y plus 1 squared. So very annoyingly, perhaps, this one, by the exact same logic as above, goes to a. Oh, I lied to you. I lied to you. I almost said a is greater. It's not the exact same logic as above, is it? A squared this part is the exact same logic. But which part comes into play in a big way here? The or 0. Y might be positive. Or here, let me say this. Quantity A, quantity B. B is always 0. A is sometimes positive, sometimes 0. And another thing that you'll learn a lot of if you do a lot of QC questions is this, getting an answer that's sometimes one way, sometimes another, is very often leading into the real correct answer. And it turns out, Sophie, you were right. Of D. Not enough info. Because sometimes they are equal, 0, 0. Sometimes A is greater, positive versus 0. If A is sometimes positive, sometimes 0, A sometimes greater, A and B sometimes equal. If they were equal, that would be answer choice C. If A was greater, that would be answer choice A. And if you get any flip-flop like that, oh, depending on the circumstance, we might get this answer or that. It's a good fuel into answer choice D. Not enough info. In fact, we often say D doesn't really mean not enough information. It means you have enough information to prove that it is sometimes one way, sometimes the other way. And that's why you pick D. All right. I've now survived almost giving you the wrong answer on both of these questions. I don't know what was happening. We got an A, we got a D here. And now let's come down and look at the third question. On this one, we know from the start that A is greater than 0. And we've got these crazy quadratics. We've got these crazy quadratics. 12a squared plus 10a minus 19. 12a squared plus 4a minus 9. I do not want to put these into the quadratic formula. And as we just saw in number 2, I actually can't because I don't know really the equal 0. So I'm not going to be able to like solve for A. But our mission is still to compare. And sometimes we can compare by basically canceling things out from both quantities. or basically doing algebra on both quantities, doing the same algebra. Some caveats on this in a minute, but I'll just show you how this plays out in this particular question. 12a squared, 12a squared, well, that's the same. So I can just say, get out of here. Or effectively, subtract 12a squared from both sides. I'm just going to draw it here by canceling them out like this, but we're basically subtracting. Now I've got 10a minus 19 versus 4a minus 9. I'm going to do the same thing to both sides again. Minus 4a minus 4a. Now I've got 6a minus 19 versus negative 9. Okay. Maybe I can get all my positive numbers together. So I'm going to add 19 to both sides. And this is going to lead me to, I'll continue over here. Over on the left, now I just have 6a. And over on the right, quantity b, I have negative 9 plus 19. I have 10. Let's keep going. Let's just keep doing the same thing to both sides. Divide by 6, divide by 6. A versus 10 over 6. Or if you like decimals, that's a versus 1.667. Yeah, 1.66 repeating. Basically 1 2/3. We'll come back to what the final answer is, but this move of basically doing algebra to both quantities is really, really helpful. It is called, in some of our resources, we call it simplifying across. In other times, we call it the hidden inequality. The idea being you can do algebra to this as if it was an inequality. There are other whole free prep hours just on that. So if you look up hidden inequality, you should find lessons in more detail about this taught by some of my colleagues. Why does it work? Well, imagine it's a basketball game, my team versus your team. My best player scores 50, your best player scores 50. Well, those points canceled each other out. So we could basically cross out those 50 points from each of our best players and see who won among everyone else. And it'll be the same as who won overall, because those 50 points on each side just canceled out. In terms of who won in the end, we can just subtract them from both teams. That's basically what we're doing here. Both teams got a 12a squared, so just ignore it. That's not going to help us figure out which is greater. Both teams got a 4a, just subtract that 4a from both. You know, it's not going to matter. They both achieved at least 4a, so if we ignore that 4a, we still will be able to find out who won. There is one major caveat to this, which is that you do not want to multiply or divide by negative numbers when doing this. It goes haywire. You also sometimes don't want to multiply or divide by variables. For more on that, check out one of those other free prep hours on the hidden inequality. But addition and subtraction and dividing by positive numbers, those are the things we did here. Those are totally legit at any time to do to both quantities. And they can sometimes lead you to a very nice and simple, basically new look at the comparison. Instead of these crazy things here, I now know it's as simple as saying, which is greater, A or 1.66666? The answer is, again, going to be D, not enough info. Because I know A is positive, but that's all I know. I don't know if, here, I'm interpreting A is greater than 0 as A is positive. But like A could be 1, A could be 2, A could be 1.6, A could be 1,000,000. Any positive number is a fine option for A according to this rule. And so I'm going to have some options for A that are on either side of this 1.66. Sometimes A will be larger than this. Sometimes A will be less than this. And that's why we picked D for this question. So we landed here tonight on a few things from this slide here that are sort of about inequalities, but they're also about just quantitative comparison questions in general, which certainly are something that I recommend studying since they show up a lot. Thanks for joining. I hope this helped a little bit for anyone watching with quadratics, at least just like shaking off the dust of, okay, how do we FOIL? How do we reverse FOIL? And that this maybe showed some other tricks as well in terms of things to have on your mind if you see a quadratics question on the test. There's one other tiny thing that sometimes shows up related to quadratics, which is actually quadratic graphs. There is like a graphing category within GRE geometry, the coordinate plane, and a quite rare but possible type of graph you could see is a parabola. That is an x-squared graph. I covered that in a coordinate geometry free prepper that you can see on the YouTube channel as well. So if you want to see the geometry version of this x-squared kind of math, go check out that coordinate plane free prep hour. All right, thanks y'all. Let me know in the chat if you have any questions about what we just went through on this slide or anything else. Thanks for joining for this hour, and good luck out there. Good luck on your tests. I hope you watch some of those other lessons I mentioned. Have a good night. Thanks for watching.